Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 30 to 33 of the Algebra 1 Common Core New York Regents exam for August 2016. Alright, let's take a look at question 30. It says, the graph below shows two functions f of x and g of x. So this is f of x, and then this absolute value function is g of x. Question: state all the values of x for which f of x is equal to g of x. So before we solve this problem, there's something I'd like you to recall. Now, when we're talking about two functions being equal, what does that mean using a graphical representation? Let's address that. Graphically, two functions, in this case f of x and g of x, are equal when where they intersect. Okay, so what this problem is asking us in essence is, what are the x coordinates of the points of intersection of these two functions? So let's write down what our objective is. So f of x is equal to g of x where the two functions intersect. So that's what we're looking for. Where do the two functions intersect? Alright, let's go ahead and indicate those. There are 2 points of intersection here. Let's call the first one intersection 1, and then the second one, let's call it intersection 2. Okay, so as you can clearly see, we can easily determine the coordinates of the points of intersection. So for intersection 1, we have 1, 2, 3, negative 3 for the x, and 1, 2, 3, 4, positive 4 for the y. That's the points, the coordinates of intersection for point 1. For point 2, we have positive 1 for the x coordinate, and 1, 2, 3, positive 3 for the y coordinate. Alright, so points of intersection. Points of intersection. For point 1, let's just call it P1. For point 1, it's negative 3 comma 4. And then for point 2, the coordinates are 1 comma positive 3. So let's go back to the question and make sure we're answering exactly what we were asked to find, okay? We're asked to state all the x values for which the two functions are equal. So all we have to do is simply extract the x coordinates of the point of intersection of the 2 points, and that will be our answer. So x values where f of x is equal to g of x are negative 3 and positive 1. Alrighty, so that is our final answer for problem number 30. Alright, let's take a look at question 31. It says, find the zeros of f of x equals the quantity x minus 3 squared minus 49 algebraically. So before we get started, let's note something concerning what the term zeros of a function means. Okay, so something you want to note is as follows. The zeros of a function, let's say the function is f of x. Now, if you're asked to find the zeros of a function, what on earth does that mean? Algebraically, the zeros of a function are the x values where the function attains an output value of 0. Okay, so That's what the zeros mean. That's what we're asked to find here. Now, since we're dealing with a quadratic equation, there is something that you would like to keep in mind. Let's consider the following reminder. Whenever you square root, both sides when solving a quadratic, remember to introduce the plus or minus sign. Okay? Introduce the plus or minus. This could be introduced either to the left or the right side. Ideally, if you introduce plus or minus to the numerical part of your equation, it's easier to isolate the variable. Okay? So this is something to keep in mind. Now, what are the steps that we're going to employ to find the zeros of this quadratic function? So let's consider the steps real quick. The steps can be grouped into two broad categories. So steps. First of all, what we're going to do is follow what the instruction says here concerning what the zeros of the function is. We're going to set the function equal to 0. That will create a quadratic equation. Now, after creating the quadratic equation, we'll simply solve for x. We are going to use our algebraic procedures to get x isolated. Alrighty, so let's go ahead and get started. So part 1, let's set the function equal to 0. Okay, so when we set f of x equal to 0, what are we going to have? We're going to have x squared minus, no, I wrote it incorrectly, x minus 3 quantity square minus 49 equals 0. Okay. Now we've set it equal to 0. Now we're going to proceed to isolate x. Now to solve for x, these are the sequence of steps that we're going to execute. First, we'll get rid of the 49 by adding 49 to both sides. We'll then get rid of the square by taking the square root of both sides. Now when we root the square root of the square, we're going to use this fact that we recalled here. We'll introduce plus or minus to one side of the equation. And then the last move will be to add 3 to both sides. That will result in x being isolated, which is the state that we want. Alrighty, so let's go ahead and do it. First step, add 49 to both sides. What we're doing now is trying to solve using the properties of equality. So we have x minus 3 x minus 3 quantity square equals 49. And then we'll take the square root of both sides. Okay, so remember this fact that we're about to use applies to even roots, okay? And one of the even roots is square root. So anytime you take the even root of a root that's also even, you want to introduce what? A plus or minus. So we're going to have x minus 3 equals plus or minus 7. This is because when you raise positive or negative 7 to the second power, you end up with positive 49. That's why we have to introduce plus or minus. Okay, now that we have the root, this exponent taken care of, the last move will be to get rid of this 3. But in this situation, we have two equations in one. Okay, x minus 3 is either plus or minus 7. So to proceed, we're simply going to split the equation into two. Alright, so x minus 3 equals the negative part, and then x minus 3 equals the positive part. See how easy it is now? So to finish this off, we'll just add 3 to both sides of the left equation. And I have x equals, signs are different, subtract and take the sign of the bigger. And then over here, add 3 to get x isolated. And we have x equals 7 plus 3, which is 10. So our zeros, the x values that make this function attain a value of zeros are x equals, let's organize them in set notation, -4 and +10. These are the two x values that causes this function to have an output of 0. It's also known as your x-intercepts. Alright, let's take a look at question 32. It says solve the equation below for x in terms of a. So one thing you want to keep in mind when solving a formula for a specified variable is as follows. Let's consider the following tip. It might not be directly applicable here, but there are problems on the Regents exam where you're asked to solve a formula for a specified variable. Okay, so when solving a formula for a variable, in this case x is what we're solving for. We're not looking for the solution, we're just isolating x. Okay, when you're solving a formula for a variable, collect all terms with that variable to the same side. Okay, that makes it easy to get that variable isolated. When you have all of them together, you can either factor or do what you have to do to get that variable isolated. Now, in this equation that we have here, 4 times ax plus 3 minus 3ax equals 25 plus 3a. This is nice because all the terms with the x's are already on the same side of the equation. So you have this term here and this term here. Had it been we had another term with an x attached to it on the right side, we will want to move it to the left side of the equation. Okay, so let's simplify this term so we can have only the terms with the x's attached to it on the left side. You see this 3 right here, that's a problem, we need it gone. Okay, so to address this parenthesis, we distribute, so that gives us 4ax plus 4 times 3 is 12 minus 3ax equals 25 plus 3a. Alright, now let's move the 12 over to the right side. This can be accomplished by subtracting 12 from both sides of the equation. And now we have 4ax minus 3ax equals 25 minus 12 is 13 plus 3a. Now we can combine these two terms. Sometimes you might not be able to combine. In that case, you will have to factor out the target variable and divide to get it isolated. But this is nice, we can combine them. So 4ax minus 3ax, you just simply subtract the coefficients. 4 minus 3 is 1. So 1ax can be written as ax, because 1 is a multiplicative identity, equals 13 plus 3a. Last step is to get x isolated. We'll divide both sides by a, and we'll have our final result, x equals 13 plus 3a divided by a. Alright, there goes your final answer for question number 32. Okay, let's take a look at 33. It says the data table below shows the median diameter of grains of sand and the slope of the beach for 9 naturally occurring ocean beaches. Okay, the diameter is the input value x, and then the slope is y. Now we have to write the linear regression equation for this set of data, rounding all values to the nearest thousandths. So we're looking at 3 decimal places here. Okay, so first things first, the formula For linear regression, the way it's structured in the calculator is y equals ax plus b. Alright, like y equals mx plus b is the same thing, but the slope here is a. Now, this is the formula that we're going to be using. Alright, so now let's consider the sequence of steps that we're going to use to have our calculator generate the result for us. Alrighty, so steps. Number one, we're going to enter the data into the calculator. Enter the data into the calculator. And then we're going to turn diagnostic on. Now, there are different calculators that can be used to solve this problem. Different kinds of graphing calculators. I'm going to be using a TI 83 Plus. So this step might not be exactly applicable to your scenario, so you just have to familiarize yourself with how to carry out statistical calculations in the calculator you possess, and then you can modify the steps appropriately. All right. Now, after you turn on diagnostics, you're going to find A and B. Find A and B. Find A and B. We're going to be using the linear regression function to determine what A and B are. Okay, and then after we find A and B, we're going to finally substitute into the formula. Substitute into the formula. If we know what A and B are, just plug it in here and we're good to go. So what you do first is step one. Let me bring back my calculator. So you enter this data into your calculator. Let's go home. Let's go to stats. Okay, so what you do is you go to edit. Okay, what does edit mean? Well, it gives you a bunch of lists that you can enter in your tabular values into the calculator. Think about the x values as a list, and then think about your y values as another list. So just hit enter. So you see edit right here. I already have mine populated. So what you do is you just put your cursor on the first entry on list 1, which corresponds to the first entry in the first column here, the x row. So you just enter all the values, 0.17, 0.19, 0.22. Just enter all of them. Okay, when you hit enter, it advances you to the next row. And then you go to list 2. Now you just know the configuration. It's configured or oriented vertically in the calculator, but the problem is horizontally. It's the same thing. Okay, so 0.63, 0.7, 82, 88, 1.15, 1.5, 44, 73, 11.3. Okay, when you enter it, you might want to go over your lists again to make sure that each entry here corresponds to the accurate value in the provided table, because just one little incorrect entry could throw off your answers. Alright, so we have it entered. Now you go to second function catalog. You want to turn on diagnostics. Okay, so you can scroll down to D or just hit the D button to advance straight to the D items on the catalog, and then you go to diagnostic on. Okay, and you hit that. I already turned my diagnostic on, but let me just do it again. So hit enter, says diagnostic on, hit enter. The calculator will give you a message, done. Diagnostic is now on. Alrighty. Now you go back to your statistics, and you have on the top menu here, edit, which we already used. We have calculate and we have tests. We can go to calculate. What are we looking for? We're looking for linear regression. That's what the problem says, right? Linear regression. Press enter. And it's going to carry out the computations automatically using the entry on the lists that we just filled out. Alright, so press enter. It does a little calculation. And there goes your answers. Alright, so when you're writing down your answer, you want to adhere strictly to the guidelines concerning place value. for this problem. You're told to round it to the thousandths place. Okay, so remember that the first place is tenth, and then we have the hundredth, and then the third decimal place is the thousandths. Okay, so we're rounding it to 3 decimal places. Let me just add a note here for step 3. Find a and b using linear regression function. Okay, so all I need is a and b values. So we need a and b using the output values that were generated from our calculator. So a is 17.159. We truncate there because the number after 9 is less than 5. So 17.159. And then our b value is 2.47. The number after the third decimal place is 5 or greater, so we're going to carry over. We're going to round up, so 76. Now we're going to plug in these two. Oh snap, there's a minus there. We're going to pay attention to the sign. So we're going to enter these two values into this formula. Notice it's written here y equals ax plus b. So our final result for the first part of problem 33 is the linear regression equation is y equals ax 17.159x plus negative 2.476. Well, we can simplify this a little bit more. What is minus times plus? Since the signs are different, you always end up with a minus, right? So your linear regression equation in its simplified state is 17.159x minus 2.476. Okay, so there you have it. Now, let's go on to the B part. Alright, so it says, using this equation, the B part, predict the slope of a beach to the nearest tenth of a degree. Now we're going to 1 decimal place, with grains of sand having a median diameter of 0.65 millimeters. Now remember that your diameters are your inputs or your x's, and the slopes are your y's. So what this problem is asking us to do is to use the linear regression to find out what x is when y, to find out what y is when x is 0.65. Okay, so let's write that down. We are to find the value of y when x is 0.65. That's the power of linear regression functions. You can extrapolate, you can make predictions using your regression equation. Okay, so our regression equation is y. We can write it as y as a function of x equals 17.159x minus 2.476. Where did this come from? Well, it's our answer from the first part. Okay, now you notice I wrote this as y of x. This simply means that to get an output of y, your independence or input variable is x. So what we're doing is basically taking this value and plugging it into here, which means that we have to plug it in there. Okay, let's do it. So we're going to have y of y evaluated at 0.65. Let me color code it so you can keep track of what's going on here. So y evaluated at 0.65. This is going to be an approximation. Okay, so it's going to be 17.159. X gone, replaced with the input value, which is 0.65. Hopefully that makes sense. Minus 2.476. So we're going to have our calculator do the work for us here. And then we don't want to forget to make sure that we round it to the appropriate decimal place. Okay, so we're going to do 17.159 times our input value 0.65 minus 2.476. Answer so is 8.67735. So y is going to approximately be we're rounding it to one decimal place, so it's going to be 8.6. The number after 6 is 5 or greater, so we have to round up, so it's going to be 8.7. Okay, so that goes our final answer for problem number 33B. Let's go ahead and box that. Thank you so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments concerning what we just covered in this presentation, just place your comments in the section below, and we'll be more than glad to respond to your concerns. Don't forget to subscribe to our channel for the remainder of this review series and other great math tutorials. More clips can be found on mathgotserved.com under test prep. Thanks again for watching and have a wonderful day.